So this is a problem from Leetcode.com called Find Pivot Index, and I'm going to show you how to solve it right now. And this is how the problem goes. Given an array of integers nums, calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of the index equal the sum of all the numbers strictly to the index's right. If the index is on the left edge of the array, then the sum is 0 because there are no elements to the left. That makes sense. This also applies to the right edge of the array. Return the leftmost pivot index. If no such index exists, return -1. So I hope that makes sense. Example 1 has these numbers and it says the output is 3, so the pivot index is 3. The index starting at 0 base index 0, 1, 2, 3, so that means the pivot index is 6. 1 plus 7 plus 3 equals 11. 5 plus 6 equals 11. So that's why 6 is the pivot index. And then in this example down here, you have 1, 2, and 3. -1, that means there's no pivot index because the problem says if no such index exists, return -1. And so in this case, there's no number in here where you get the numbers added up to the right of that number and the numbers added up to the left of that number equal the same value for these. So yeah, 1, 0, 2 plus 3 is 5, and then for 2 is 1 and 3, and then for 3 is 0 and 3. So yeah, it's no thing there. And then here, the pivot index is 0, which is 2, because on the left side of 2 is 0, and on the right side is 1 plus -1, which equals 0. So that makes sense. Then there's some constraints down here. If you're in an interview, you probably do want to know what those constraints are. I'm not going to go over them for the sake of time. We're going to jump into how to solve this problem and think about how I would solve this problem in my head before I try to jump to the code, or maybe even write it down or type some pseudocode to try to solve it. If you're in an interview, you need to explain how you would solve something like this before you actually start. Is a good practice. So when I'm thinking about this, the first way I can think to do this is to loop through every number in the array, because I need to find the pivot index and I need to find the leftmost one. So I need to find the first one possible. So if I just loop through these in order, that gives me the leftmost one. And as I get to 1, I can count and add up what's on the left side of that number and count and add up what's on the right side of the number. So whatever on the left, whatever on the right. And I can, as I loop through each one, I can do the same thing. I can just add up the numbers on the left and add up the numbers on the right. And once I find that the numbers that added up on the left equal the numbers that added up on the right, I just stop at that index and return whatever that index is. Now that should work, but it's called a brute force approach. Like, it will be very expensive to, every time I loop, now I have to kind of like loop through my surrounding values on each side and keep track of my indexes to try to add them up and make sure they equal. And so that can be kind of definitely not the most optimal way to do most of these problems. When you see something like that where you're doing a lot of repetitive additions, then it's time to try to find a technique that you can use to optimize, an algorithm that you can use to optimize your solution. And so in this case, let's slide over here to the answer. The optimization is to do some pre-computing, basically, and to use a formula inside of your algorithm to optimize the algorithm, so you don't have to do a lot of repeat calculations, and like every time you loop through, you got to add left and right and all that stuff. Leetcode stubs out the problem for you. I've already went through and solved it for the sake of time. You get nums passed in, which is your list of numbers from over here, nums. And so the first thing that I'm going to do, that I did, is create a total sum. So I want to pre-compute the total sum, and you'll find out why later. I'll tell you why later. So I'm going to just create a variable total sum, set it equal to 0. Then I'm just going to loop through all my nums, and then I'm going to add them to total sum. So I'm just basically just totaling the whole nums array together so I can use that total sum value for something later on. And then you have left sum. So what I'm doing is creating a left sum here. I want to keep track of the left side sum as I loop through my array. And so I'm also going to loop through the array again and keeping track of my left side sum. So hopefully that makes sense. So I'm looping through again, same way I looped through nums the first time. And here's the important part of the problem, this formula right here. Total sum that I calculated earlier minus nums of I, like whatever iteration you're at in your loop, so whatever the current num is in the loop, minus left sum, which I'm keeping track of here, equals right sum. So what this algorithm is doing is I pre-compute the total sum, and I also keep track of my left sum at all times. And then what is the problem asking you to do? Is asking you to find where the left sum equals the right sum, and that's your pivot index. So as I loop through this second time, I keep track of my left sum. I'm able to calculate my right sum using this formula, and now I can check if they are equal. Left sum equals right sum, and then I return the pivot index in that case if left sum equals right sum. Otherwise, I iterate or I add the current number to my left sum because I'm always keeping the track of my left sum. So the trick to this problem, or the algorithm to this problem, is to pre-compute your total sum, keep track of your left sum as you loop through the array the second time, and then the formula here, the trick, one of the biggest tricks to the problem is calculating the right side sum, because you need to know what the right side sum is too to be able to compare the left and right side sums. Total sum, if you think about it, if you have the total sum of the array and you have the left sum of the array and you have your current value at this point in time when you're right at this line, then you can take the total sum, the right sum, if you look at a whole array, and let me try to like visualize this. So let's say we're on 6. So if we've gotten to 6, then based on my logic, I've added these to my left side sum that I'm keeping a constant tally of in my left sum variable. But I need to calculate what right sum is. Well, I've pre-computed the sum of this whole thing. So how do I get this? Well, since I pre-computed the whole total, then I know the left side is total sum minus, or the right side, sorry, is total sum minus whatever one I'm on minus my current balance of my left sum. So if I subtract my left sum and the current thing I'm on from the total sum, then all I'm left with is the right sum, which is these two. I hope that makes sense. That's what this formula right here basically is doing to get the right sum. So then, yeah, you just see if it's equal. If it is, then you know you can stop right there, return, break out, and you would just return the index, which that will be your pivot index. That's what the problem is asking for. If there's no pivot index, return -1. So you just do that at the bottom. And so if you find it, you'll break out before you even ever get here. And then if you don't find it in this iteration of loop, you loop again. But before you loop again, you need to keep, like we said, we're keeping track of our left side sum as we're iterating through the array. So that's how this problem goes. That basically works. I've already submitted it before, but there are a few different tricks to this problem. Just knowing how to pre-compute, just knowing what to do here. This is probably something you may be able to come up with your own in an interview, but I didn't. This is something that I've done before in practice, and now it's in my tool set to help me solve problems that are similar to this. So hopefully this is something you'll practice and take note of if these type of interviews end up being the thing you have to do. And so let's talk about the time complexity, big O notation. In this case, for time complexity, you know, big O is related to the size of our input. It's how our algorithm scales, but as related to the size of our input. As our input scales, how does the time complexity scale with it, or how does it perform with it? So here, the thing I'm doing that's related to nums, which just say nums length, is basically, just call it n. I loop through nums length, so I do n operations here. That's related to the size of my input nums. And then here I also do another n operations here with this loop. But these other operations are constant. No matter how big the size of my input is, I'm only going to run this one time. But if my input is 1,000,000 here, I'm going to loop this 1,000,000 times. So big O notation for time complexity is taking in account of the things that scale with the size of the input. So here I've done n plus n, which is 2n. And in big O notation, variables like, or numbers like constants like 2 will reduce. And so the time complexity of this problem is linear big O of n. So basically for every n I have, I'm basically doing, for the most part, once it scales to like incredible lengths, for the most part, the algorithm is going to do as many operations as I have nums times 2. But once you know, the difference between a million and 2 million seems big, but when you're talking about exponential big O, you know, like n squared, it can, you know, a million nums can turn into a billion operations. There's a big difference between 2 million and a billion or a trillion. So this you know, this is kind of what big O notation is helping you kind of think through, and it's a good thing to know for writing algorithms, even if you don't do these kind of quizzy, you know, interview problems. So, and then also there's space complexity. So what kind of space is this algorithm using? Well, the space also with time, it needs to be attributed or to the size of it's based on the size of your input, or like how's it scale based on the size of your input. Nothing I'm doing here, I'm not using any data structure like a object or like an array that is holding that is doing something with my nums, or is growing and decreasing based on the size of my nums. The only thing I have really is the nums, and that doesn't count in the notation. So really, this is constant space that I'm using. I'm not using any space besides just creating these simple variables, which it won't change based on the size of my input. So yeah, so the big O notation for the space is big O of 1, or constant space. And I hope that's right. I'm just doing it from memory. But hopefully that makes sense to you. If you have questions, please leave a comment. Let me know what you think. If you have a more optimal way to do this problem, let me know. Or if you have a more optimal way to explain it, please like, follow, subscribe, whatever you're watching this on. Yeah, love to be connected with you. Thanks for watching.